In this video we are continuing on with the Ethernaut series and attempting to solve this force challenge. So let's dive right in. So it says some countries will simply not take your money. The goal of this level is to make the balance of the contract greater than 0. Things that might help, fallback methods. Sometimes we should probably attack this with another contract and see the help page above section beyond the console. So we have an empty contract, and to solve this level we need to send Ether to this contract somehow. But the thing is, for a contract to receive Ether, it either needs to have a payable function or a fallback function or a receive function. But this contract is empty and it doesn't have any of these functions. So how do we forcefully send Ether? So if you do a bit of research and go beyond the console, you'll find that there is a way with a sellfdestruct function or opcode to send Ether to any contract that doesn't even have a way to receive Ether like this one doesn't. So what does this self-destruct opcode does? So it terminates a contract from the blockchain entirely. It removes the contract bytecode from the blockchain, and because it frees up data storage on the blockchain, it costs negative gas, so it's very cheap. That's another reason why people use self-destruct, but we're going to see there are many reasons to use self-destruct, and it can be a double-edged sword because it can also easily lead to vulnerabilities and etc. So what does self-destruct do? It kills the current contract, the contract in which it is called. It deletes its bytecode from the blockchain entirely, and it sends all the remaining Ether into the contract to a specified address. Very important to note that it doesn't send all the NFTs and other assets like stablecoins, etc. stored in this contract. It only sends Ether that was stored in this contract. So all the other assets, if there were any, will be lost. So basically, to solve this challenge is very easy. You just have to deploy a contract with Ether, self-destruct it, and send the Ether forcefully into this contract. So it's a very easy challenge to solve. So let's dive a little deeper and learn a bit more because the challenge is real easy. So why do we have self-destruct in the first place? Well, previously self-destruct was named suicide. It was the suicide opcode, and one reason it is used is to upgrade contract. You have a contract A and you want to remove contract A and let users use contract B, so you want to destroy this and send all the Ether to contract B. That's one way to upgrade the smart contract. But all the state inside contract A will be deleted and you'll start with a freshly new state with contract B. So I don't know if it's the best idea, but that's one reason to use. I guess more one way self-destruct exists. Another reason to use self-destruct is to just clean up unused contracts. So if you want to be a good citizen and you want to just destroy a contract because you wouldn't use it anymore, you can use self-destruct and just clean up any unused contract. That's the second reason. And the third reason is whenever a contract is hacked, to prevent further damage, further hacks and funds stolen from the contract, you can use self-destruct to just delete the contract entirely and send all the Ether to another safe address. And there is even a real world example when this happened. So I believe in the DAO hack, in the famous DAO hack. The hack was ongoing for several days. So they could have prevented some funds from being stolen or if they had self-destruct in place. But this self-destruct can also backfire if it's centralized and one person can code this. They can easily, this way, rug pull the project, take all the funds for themselves, etc. And what happens if you send money to a contract that was self-destruct? So the balance of the address will increase, but there isn't any code on that specific address, so the Ether will just get stuck. And I want to share before we solve the challenge one more thing. So Another hack that you can perform with self-destruct is if a contract uses the balance of the contract like this for some logic. For example, we have an NFT contract and they basically, this is an NFT collection with 10, it should have 10 NFTs able to mint because you send 1 ether for each NFT and the goal, the total supply is 10 ether, so 10 NFTs. So whenever we reach the goal or less than, we can mint, but other than if it reaches above 10, then we cannot mint anymore. So this NFT should be able to mint 10 NFTs. But what happens if an attacker sends, self-destructs their contract and sends more than 10 ether into the contract? They will basically break this minting functionality because the contract checks if this balance is less than or equal to 10 ether, and you can just send 20 ether into the contract and basically no one will be able to mint even one NFT from this contract if you attack this contract before anyone mints an NFT. So let's try to solve this challenge. Just click on get new instance if you haven't already. To get new instance of this contract, go into the console and say just contract.address. This is the instance which sends some ether to. The balance should be more than 0 to pass this challenge. And if we go to the girly testnet explorer, look for our smart contract, we can see the balance is 0 ether. Let's send some ether into this contract. How can we do this? We can simply deploy a contract like so that just self-destructs and sends the amount I should have payable here, or maybe not because I have a payable too, but either way it just sends the ether you sent or into this contract to this our instance. So let's choose this contract, let's choose 3 ether. Let's deploy this and make sure we are on the girly testnet. So now we have 3 ether into this contract. Let's make sure that this address is correct. And if I call number now, I'll get the 99. So the contract exists. But now we'll attempt to destroy this contract and send all the ether into our contract, our instance contract from Ethernaut. So let's do exactly that. Pass in the address of the instance contract here and wait for the transaction to finish. And after the transaction has finished running, you can see now in the contract instance we have 3 ether. That means we have completed this challenge and you can just click on submit instance.